Here's the translation of the revised text into English, with a more engaging and exciting tone. Imagine this. In the vast depths of the universe, a supermassive black hole is tearing apart a star with its incredible gravitational force. But that's just the beginning of the story. The debris from that shredded star is now targeting something else, possibly another unfortunate star or a smaller black hole. A cosmic catastrophe is unfolding step by step. Back in 2019, astronomers witnessed a once-in-a-lifetime event. A star ventured too close to a massive black hole and was torn apart by its immense pull. What was left of the star formed a disk of debris swirling around the black hole, like a graveyard in space. But the story doesn't end there. Over the years, this debris disk has expanded, and now it's crashing into another object, possibly another star, or a smaller black hole. And every 48 hours, that object slams into the disk, triggering powerful bursts of X-rays captured by NASA's Chandra X-ray Observatory. Think of a diver jumping into a pool. Every time they hit the water, there's a splash, right? Well, this cosmic event is just like that. The star is the diver. And with each collision, there's a massive splash of gas and X-rays. Scientists have documented many cases where an object ventures too close to a black hole and is torn apart in a single flash of light, events they call tidal disruption events. But this one stands out. It involves a rare, repeating burst of explosions. In recent years, astronomers have discovered a new class of bright flashes coming from galaxy centers, only detected in X-rays and happening repeatedly. And finally, we may have found the answer. This extraordinary event, known as AT 2019 KIZ, was first discovered in 2019 by the Zwicky Transient Facility. By 2023, astronomers continued their investigation into this stellar graveyard, using both Chandra and the Hubble Space Telescope. The results are fascinating. Chandra's data revealed that these X-ray bursts are happening like clockwork. Every 48 hours, it's like a cosmic ticking time bomb. Meanwhile, Hubble's ultraviolet data allowed scientists to measure the size of the disk around the supermassive black hole, showing that it's now so large that objects orbiting the black hole are smashing into it, creating massive explosions. This discovery is a breakthrough in understanding the origins of these regular bursts. We now realize it takes a few years for these bursts to begin, because the disk needs time to expand far enough to collide with another star. Finding more of these events will allow scientists to measure how common objects in close orbits around supermassive black holes are. Some of these could even be perfect targets for future gravitational wave observatories. NASA's missions, using revolutionary tools like Chandra and Hubble, are part of a growing global network of missions with complementary capabilities to monitor these kinds of changes and unlock the mysteries of how our universe works. With each new discovery, we're getting closer to understanding the wild forces shaping this vast cosmic expanse.